Hey everyone, welcome to this video. We are going to talk about vanishing and exploding gradients, which is a problem you may encounter when training a network or model. So first off, what are vanishing gradients? During backpropagation, the gradients of early layers are calculated by multiplying the gradients of later layers. So if you multiply a bunch of small numbers together, like 0.1 times 0.1 times 0.1, you will get even smaller numbers. Small gradients will lead to small changes in weights, and learning stops. So in this diagram, we have a gradient of 0.1, and as it goes through the layers, there's more multiplications of small numbers, so the gradient gets smaller and smaller, which will make the weight updates smaller and smaller, and learning stops. What's an intuitive opposite problem? Exploding gradients, where if we multiply a lot of big or large numbers together, you will get even larger numbers. Large gradients lead to large changes in weights. Learning destabilizes. So here we have a gradient of 10. As it goes through the layers, there's more multiplication of big numbers. So the gradient gets larger and larger, and learning destabilizes. And here's a quick recap. So if the changes in weights are too small, learning stops. If the changes in weights are too large, learning destabilizes. Let's talk about layers. So a model with many layers, gradients are more likely to rapidly shrink or rapidly grow because there's more layers, so there's more multiplications. Rapidly shrink is vanishing gradients, and rapidly grow is exploding gradients, which will cause issues with learning. So a really naive approach might be, okay, let's use a model with less layers. But there's an issue with that. Because a model with many layers is also needed for learning complexity. So as a simple example, if we want a model that's really good at telling the difference between a picture of a dog or a picture of a cat, we will probably want more layers than less layers. But that's the issue though. We need many layers to learn complexity, but if you have many layers, this can cause issues with learning. So how can we deal with vanishing and exploding gradients without having to resort to using less layers? Here are some solutions. 1. Use a different activation function besides sigmoid, which we will go into more detail in the next video because I want to keep this video as lean as possible. You can fiddle around with initial weights because good initial weights have less probability of vanishing gradients. You can try different architectures. Later in the course, we will learn about LSTMs, which help with vanishing gradients. In fact, if you go to the course directory and go to RNN and lstm.ipynb, as you can see, we will work with LSTMs, which help with vanishing gradients, residual connections, which we will also talk about later on in the course. As for exploding gradients, again, you can fiddle around with initial weights. Good initial weights have less probability of both vanishing gradients and exploding gradients. Gradient clipping, which I find pretty intuitive. So for example, we could say we have a min of -3 and a max of 3. Gradients that are smaller than -3 will get set to -3. Gradients that are already in between -3 and 3 will stay the same, like 1.5 and 2. And gradients that are bigger than 3, such as 25 and 100, get set to 3. And just like vanishing gradients, later in the course, we will learn about LSTMs, which help with vanishing gradients and exploding gradients. Okay, that's it for this video. Thanks for watching.